Okay, guys, we're continuing on with logarithms, section 5.4. So before we went over 5.4 part 1, now we're going to go into 5.4 part 2. We're going to learn a new property here. So it's called logarithms of quotients. Remember, quotient means divide. The quotient rule corresponds to the quotient rule for exponents. So remember, if we have a to the power of m divided by a to the power of n, what do you do with the exponents? The rule is you subtract them, and you would have a to the power of m minus n. So, for example, if you have x to the power of 8 divided by x to the power of 3, you're supposed to get x to the power of 5. You're subtracting. Now keep in mind, this is when you have the same base. So the quotient rule in the box says the log base a of m divided by n equals log base a of m minus log base a of n. So you are allowed to when you see a division, you're allowed to split it up into two separate logs separated by a subtraction sign, and the denominator has the subtraction sign in it. So in example 4, we want to express as the difference of logs. So in A, if we have to express as the difference of logs, it means we're going to have a subtraction sign. So this would be log base t of 8 minus log base t of w. You simply do the numerator as a log minus the denominator as a log. So let's try another one, letter B. A log of m divided, or log base m of a divided by 7. To express it as a difference of logs, it would be log base m of a, then a minus sign for the denominator, log base m of 7. Letter C, log of r divided by s would be log of r minus log of s. Now, keep in mind, the reason, even though we didn't simplify anything here, remember that we're learning these properties so that we can apply them. It helps us simplify logs when we're dealing with actual numbers. So example 5, what we're going to do, it says express as a single logarithm, also known as condensing. So the property in the box also states that if we have log base b of 64 minus log base b of 16. The property says we're allowed to write this as just a single log. So it would be log base b of 64 divided by 16. And so this property helps us to simplify, if we can. What is 64 divided by 16? That would be 4. So we are allowed to simplify further, and it's log base b of 4. So let's try another one, letter B. Log of 100 minus log of 10. So it would be log of 100 divided by 10, and then we can simplify that. Let me clean that up a little bit. So we're allowed to divide if we can. 100 divided by 10 is 10. And then we can simplify this log. Remember, log base 10, or sorry, not base 10. It actually is base 10. Remember, it's common log. When a log is not shown, it has a base of 10. My writing is all out of whack tonight. So this is log base 10 of 10, which we know is 1. Remember, it's a 1 because 10 to the power of 1 is 10. Okay, letter C. This one's very tricky. We sure do crank up the difficulty here on this one. So we have a minus sign. So what we're allowed to do, actually what I need to do is get rid of this radical. We don't want radicals in logs. We actually want to have those as exponents. So let's take care of that first. So just carry down the log of x to the power of 5 minus 3 times natural log of x to the power of 2/3. So we have learned in previous lessons that when you have a cube root of 2, that can change to an exponent being 2/3. Now, what to do from there? It's still very confusing on what to do because we actually have this 3 out in front. So what we want to do is move that 3 out with the exponent, over to the right with the exponent. So again, let me bring down the ln of x to the 5th, bring down the minus sign, and then ln of x to the power of 2/3, and then we're gonna multiply that by 3. Remember, the 3 in front of a log can be changed over to an exponent. So now we are gonna multiply those exponents. So 2/3 times 3, 2 times 3 is 6, divided by 3 is 2. So 2/3 times 3 is 2. So we had to do quite a bit of work there just to get this back into a normal looking log. Now, it's very simplified. Now we can use our new property, which is our quotient property. So we can say ln of x to the 5th, excuse me, let me erase that. Nope. Make the fraction, and it would be x to the 5th divided by x to the 2nd. And then we can go one step further here. We can simplify x to the 5th divided by x to the 2nd. We have exponent rules here, so we can subtract to get ln of x to the power of 3. Then finally, that's our answer. We have now condensed it as a single log. All right, next up, simplifying expressions of the type log base a of a to the x power and a to the power of log base a of x. So there's some properties here in the boxes that say when we have log base a of a to the power of x, it's got to be equal to x. It has to be equal to x. This is a shortcut property because remember, this has to do with exponents, and remember your little base a, it's saying a to the power of what equals a to the power of x. Well, it has to be x here. That has to be x to make them identical. So it's just a little shortcut property. So let's apply that here in example 6. So we're going to simplify here. So log base a of a to the power of 8, the property says it's just 8. Again, that makes sense because this little base a right here, a to the power of what, would equal a to the power of 8. Well, fill in the blank there. It must be 8. So it's just a shortcut property. Okay, the next one. Even natural logs, we can use this property. ln of a to the power of negative t. Remember that ln of e, or ln is log base e, and then carry down the e to the power of negative t. And you can see now this property applies. You have this little base e, and the big base E. So therefore, the shortcut is, your answer is negative t. So remember, keep that in mind. It came up last lesson that whenever you have ln, called the natural log, that is log base E. All right, letter C. Now, I don't see a base here, so this is called a common log. So even I fill it in with a little t. Remember, when the base is not showing, it's a little 10. So the property applies here. So we have log base 10 of 10 to the power of 3k. What would that have to be? That would have to be 3k. So just a shortcut property. All right, so example 7s have to do with the second box at the top middle of the screen. It says when you have a to the power of log base a of x, you're just going to get an x. You're just going to simplify it to an x. So this is just another shortcut property. So let's apply that to example 7, where it says just simplify. So we have log, or in A, we have 4 to the power of log base 4 of k. So when we see those 4s match, that means our answer is just gonna be k. Letter B, it's e to the power of ln of 5, a little confusing there, but remember, when I'm dealing with this e and I see an ln, remember that I like to change it to a log base e. So this changes to carry down the e, then ln converts to log base e and drag down your 5. Now you can see that the property applies, the property at the top middle of the screen. So when you see those matching e's, your answer is just going to be 5. Number 7. I'm going to take my log and my exponent. I'm going to fill in with the power of the base of 10. So it makes a little more sense now. And I go, oh, those 10s kind of match up. I'm using my shortcut property again. And my answer is 7t. All right, so in the next examples, we have now learned the properties of the logs from the previous day in part 1 and now in part 2. So what we're going to do is apply the properties, all that we learned. So let's see what our goal is example 8. It says express each of the following as sums and differences. Express as sums and differences. That means I want to split this up. So what I want to, when I have a fraction here, I'm going to do log base y of x to the power of 2. Then I'm going to put a plus log base y of y to the 5th power. Remember, I'm using my kind of sum property that I learned the other day because the numerators are multiplying, so we're allowed to split them with a plus sign. And then what about the z to the 4th on the bottom? That's a denominator. So I'm using my quotient property, which says I put a minus log base y of z to the power of 4. Now, I do need to try to simplify. I'm not just going to leave it like this. So I'm going to use some other properties as well. When we have log answers, we typically don't want to leave our answers with exponents. So this guy's going to move out in front. So this is 2 times log base y of x. Bring down your plus. Now this guy here, log base y of y to the 5th, that's just going to be 5. It's a property we just learned on the previous page. The property on the top left here. So we shortcut that and we say it's got to be 5 because y to the 5th is equal to y to the 5th. And then minus. The only thing we can do for this guy is we move this 4 out in front. So this would be 4 times the log base y of z. And then we're done with that problem. So let's try another one. We have, by the way, at the top there, I believe that's supposed to be an a to the 5th. And yeah, we're going to treat that as, sorry, not a to the 5th, y to the 5th. So let's split this up as sums and differences. So we're going to have log base b of a, then a plus, because we're doing the multiplication property, which says we're allowed to separate them by pluses. So then log base b of y to the power of 5. Now we move on to the denominators, the m and the n. And for the denominators, we put minus signs in front. That's the quotient property. So minus log base b of m cubed. Then another minus for the n in the denominator. Log base b of n to the 4th. Okay, now let's clean some things up. The first log here with the a. You can't do anything there. There's no exponent to move out in front. No properties to use there. Just bring it down. The second one with the y to the 5th, let's move that exponent 5 out in front. So plus 5 times log base b of y. And then the third one, same thing here. 3 moves out in front, so minus 3 times the log of base b of m. And in the fourth one, the 4 comes out in front as well, so minus 4 times the log base b of n. And that's all we can do there. We can't do, there's no other properties to use. Okay, let's move down to example 9. These are the last two of my lesson. Now in these two, we're going to express them as a single logarithm. So now, let's, before we put them together as a single log, we have to take this, move it over as an exponent, and take this and move it over to the z as its exponent. So let's do that now. So the first log would be log base b of x to the power of 5. And then the third one would be plus log base b of z to the power of 4. Now we want to express it as a single log, so let's condense it. So we're going to do anything that has a positive belongs in the numerator. Anything that's a negative in front, we need to make a fraction, put a denominator. So they all have log base b, so let's put log base b. The first log has a positive, so x to the 5th goes on top. The second log with the y has a minus in front of it, so that means the y goes down to the denominator. And the third one has a positive in front of it with the z. So that means since it has a plus in front of it and it's positive, that belongs in the numerator. And I can't simplify anything there. I expressed it as a single log and it's good to go. All right, let's try another one. This does cap off the lesson with a pretty difficult problem. So first thing I notice is there's no exponents I need to move here or make new exponents, but I have a minus sign. So that means I'm going to do ln with a fraction. The first natural log is positive with the x plus 1, so put that in the numerator. The second ln has a minus sign in front, so put that in the denominator. Now, I'll be honest with you, if you stop there, I don't blame you. It's hard to pick up on what happens next. But this kind of uses an old algebra thing of when we used to simplify fractions. Now, and when I mean simplify fractions, sometimes we can factor the polynomials. Like, for example, on the denominator, we have x squared minus 1. If you recall, that can be factored into x plus 1 and x minus 1. Remember, that's called a difference of squares. Notice something. X plus 1 and x plus 1 can actually be canceled. And what does that leave us with? Bring down your L of n. There's nothing left in the numerator because we canceled out that x plus 1. So if there's nothing left in a numerator, we must put a 1. What's left in the denominator is x minus 1. So yes, that was a very, very challenging problem. I'll be very impressed if people get this one right on the test. All right, guys, that's the end of the lesson. Have a great day.